Hi guys, welcome to the first part of 3.10, which is trigonometric equations. So we're going to dive into these equations. We're going to keep it pretty simple today, except we will introduce some new notation. You've seen it a little bit before, but hopefully that makes sense. So it says consider the equation sine of x equals 1/2 on the interval shown below. Notice the x coordinates where it intersects the line are on the given interval. So we want to figure out where sine of x is going to equal 1/2. And I can see these points of intersection here. We can also think about it with our unit circle. Where does sine equal 1/2? Well, that's going to happen here. It's going to also happen here, and then keep going around the circle. So those points would be pi over 6, 5 pi over 6. That's this one and this one. 13 pi over 6 if you went around the circle again. And then if I add another 6 or 12 pi over 6, that would be 17 pi over 6. And then if I go backwards, that would be negative 7 pi over 6. But those aren't all possible equations because I could keep going with my wave forever and ever and ever. So I want to represent essentially that there's two answers, but they will repeat every time it goes around the circle. So here's how we're going to write this. We're going to start with pi over 6. And we know that a full circle is 2 pi. So I'm going to say plus 2 pi k, meaning every value of k, if I add 2 pi, if I add 4 pi, if I add 6 pi, if I add 8 pi, it will still get you a sine of 1/2. My other solution is 5 pi over 6. And if I add a full circle to that, think about if I took 5 pi over 6 and I added 12 pi over 6, because that's 2 pi, that gives me 17 pi over 6, and that's what I have on my original. So I can keep adding and keep adding. K is some integer, meaning it could be positive 1, positive 2, negative 1, negative 2, negative 1,000, okay? However, an infinite number of times. All right, so let's look at example 2. Think about this just like you were solving an equation. So if you were solving 2x minus 1 equals 0, I would add 1 and then divide by 2. Same idea here. I'm solving for cosine of x. So 2 cosine of x equals 1. Cosine of x equals 1/2. And so we're asking ourselves, where does cosine equal 1/2? Notice that we're not using that inverse notation, so I don't care about my restrictions here because I want all possible values. Well, they've actually pointed it out for you. It's going to happen at pi over 3 and at 5 pi over 3. And we know that that has a period of 2 pi, a full circle. So we're going to say pi over 3 plus 2 pi k, an infinite number of circles around, and 5 pi over 3 plus 2 pi k, where k is some integer. That's all the general solutions. Okay, let's do a couple more on the back. Example 3. So we want to find all the places, all solutions where sine is negative square root 2 over 2. So let's just figure out in my unit circle first where that is. Sine is the y value, so it's going to happen here and here. Okay. So that is at 5 pi over 4 and 7 pi over 4. So how we represent all of them is we just say 5 pi over 4 plus 2 pi k and 7 pi over 4 plus 2 pi k, where k is some integer. Okay. For part B, now this looks kind of complicated, but remember you're just solving an equation. You're trying to get all the cosine of x's on one side, everything that's not a cosine of x on the other side. So I'm going to minus 14 cosine of x. And I get 4 cosine of x minus 7 equals negative 5. 4 cosine of x equals 2. Divide by 4, and I get cosine of x equals 1/2. So we're trying to figure out where does cosine equal 1/2. That's going to happen here and here, which is pi over 3 and 5 pi over 3 plus 2 pi k, because I go around the circle an infinite number of times. Okay. Now let's do a few with factoring, and then we'll be done with this one. Okay. So I don't want to do the ones with the calculator because I want to give them to you on your unit circle. All right, so this one right here, solved by a factoring. Notice it says only on the interval 0 to 2 pi. So I'm not going to add that plus 2 pi k. I'm only looking on my circle. So I'm going to add 1. divide by 4. And then to get sine of x by itself, I need to take the square root. When I take the square root of 1/4, I take the square root of the top, square root of the bottom, and I get 1/2. But when I take the square root, remember you need to count for the positives and the negatives. So I'm going to say plus or minus 1/2. This is something that people forget a lot. When I take the square root in my equation, I need to account for the positive and the negative. So where does sine equal positive 1/2 or negative 1/2? Well, that's going to happen at all my big X, little y's. Okay, so that's going to be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Notice I didn't add plus 2 pi k because it just wanted in this interval 0 to 2 pi, not all general solutions. All right, let's look at example 6, more factoring. If you remember from when we did this with exponentials, it could help if you rewrite these as u's to factor it. You can factor however you like. I'm not going to go through factoring in this video because we've done it a lot. Take a second, try and factor it. You get 2u plus 1 and u minus 1. I'm going to set each of those equal to 0. And this is what I get. Remember that u here represented sine of x. So I'm going to go ahead back and replace that. So I'm going to say, where does sine of x equal negative 1/2 and where does sine of x equal 1? And both of those will end up being solutions. All right. Again, I factored, I set them equal to 0, and then I replaced my u with sine of x. So sine is my y, so where does sine equal 1? It's just at pi over 2, that's at the top. And then sine equaling negative 1/2, that's going to happen here and here, which is 7 pi over 6 and 11 pi over 6. Okay. All right, let's do one more. Number 7. All right, write this down on your paper. No dividing by trig functions. So I know your immediate instinct on this one and ones like it is going to be to divide by tangent on both sides. But you can't do that because we don't know if tangent of x equals 0. And we don't want to divide by that if we don't know if it can equal 0 or not. So your strategy for this is going to be to get everything on one side. So sine squared of x, tangent of x, minus 2 tangent of x, move that over to the other side, equals 0. Okay, get everything on one side, no dividing by trig functions. So once I have it here, then I see that there's a GCF. Okay, I see that tangent of x is in both of these. So I can factor that out. And I get sine squared of x minus 2 equals 0. Well, just like I did up here when I had my u's, I set them equal to 0 to solve for u. I'm going to set each of my factors equal to 0. Okay, let's start with tangent of x equals 0. So that is sine divided by cosine. That's going to happen at 0 and at pi. Okay, at 0, I'll have 0 divided by 1. At pi, I'll have 0 divided by negative 1. Those both equal 0, so tangent is 0. For this one, I'm going to have to add 2 on both sides, and I get sine squared of x equals 2. Take the square root. Don't forget your plus or minus. And we're asking ourselves, where does sine of x equal plus or minus square root of 2? Now, square root of 2 is bigger than 1. Remember, sine of x only goes between negative 1 and 1. So this is never going to happen. Kind of like if you remember with our exponential, if we got something like this, 2 to the x equals negative 3, never going to happen. Okay? So we don't even need to really worry about that one. I'm just going to have the answers from the first factor being set equal to 0, which is 0 and pi. So a lot of this equation stuff is all things that you've been doing. It's kind of combining some ideas of exponential that we worked with, along with our unit circle and finding where those values happen. Plus 2 pi k just means I want to give an infinite number of solutions as I go around the circle or go backwards around the circle many, many times. So that wraps up just the first part of 310. There will be some more with inequalities as well. But I hope you have a great rest of your day.